Good morning. It's my pleasure to introduce your keynote speaker for this morning, Dr. William Penuel. Upon hearing a little bit about his background and expertise, I'm sure that you will come away wanting to hear more. Dr. Penuel is currently a professor of educational psychology and learning sciences at the University of Colorado Boulder. Prior to joining the faculty, he spent over 13 years at SRI International, developing a broad program of education research in STEM, education research in STEM education. During those years, he conducted a variety of design, assessment, and evaluation research studies, developing a nationally recognized expertise in educational technologies, classroom assessment, implementation research, and large-scale cluster randomized trials of educational innovations. His full biography is part of your take-home package, but suffice it to say that the footprints that he is yet to leave on the educational landscape will be deep and meaningful for future practitioners and students. Please join me in welcoming Dr. William Penuel to our Active Learning Symposium.
Thank you, Dr. James. So I'm really honored to be here with you, this amazing group of mathematics and science teachers here. And I want to be the first to point out it would be very ironic and inappropriate for me to talk to you for 30 minutes about active learning. So though I have been tasked with defining active learning for you, I'm going to engage us together in that task. I'm going to put a few ideas on the table, but I want us to be active learners and thinking together. The core premise of everything that I do is, in my own work, is that research that in my field, which is learning sciences, that we produce, it's very useful, but it can only get us so far. The problems of implementing this in your classroom, in complex schools and districts, as you know, those are really big problems in their own right. And so we have to actually work together, blend the wisdom of practice with research-based evidence to really create a system of science education, STEM for all. Think about that. That means addressing the fundamental inequities of opportunity that exist in our country, access to courses, but also within those courses, access to the learning opportunities within them. If we want to realize that vision, we're all going to have to be learners together. So I stand here before you today humbly to you who know so much about engaging your students in science and mathematics learning. And I hope to give voice to some of what you already know, but also to challenge us together to define a vision of STEM that draws on the best of research knowledge and wise practice to expand learning opportunities for all students. It's a tall order, but it's an important one. So as I began to prepare this talk, I thought, what do we learn in the learning sciences that really are important to bring forward? One is this idea of learning trajectories or learning progressions. And this is something that's been developed both in mathematics and science education. And it really comes down to this. A few ideas are better than a lot of ideas. And focusing on the core ideas, the ideas that professional scientists and mathematicians use generatively to figure out new problems that they've never seen before. That might be plate tectonics in earth science or the distributive property in mathematics. These are the ideas that if kids really get them and they work with them over and over again, then they'll be able to solve new and unusual problems. The idea that learning of these core ideas is something that takes place over many years, not days. If we're just designing individual lessons, we're never going to actually really build deep understanding of content. But it's also important to not take a deficit view of our students. The ideas are not just misconceptions. These ideas that are resources that we can draw on. And we have to see our kids and their ideas as resources that we begin with in our instruction. Those are some big ideas here. The map here comes from the work of my colleague Jer Comfrey at NC State. And it's an illustration of a learning trajectory that is well reflected, actually, in the Common Core state standards in mathematics. And it's an illustration of how this is, how a big idea has actually come into play in informing new standards, research into practice. We've also learned a lot about the role of interest as a catalyst of learning. Robert Tye and Adam Maltese conducted studies of people who went into STEM fields. There was a much higher probability of going into a STEM field if you expected by eighth grade to go into a STEM field. We know that out-of-school experiences in families, communities, museums like the one you see here from the Exploratorium are incredible sources of inspiration that lead people into STEM careers. How do we captivate interest and build off of interest and connect to it in our learning in schools? Neuroscience has advanced an incredible amount of knowledge about learning. Now, a lot of it is really not yet built to help us understand exactly what we need to do in schools, but there's a couple of big ideas that are really important. One is that the way we've been thinking about reason and emotion all these years has been basically wrong in the West. That our emotions are important cues about when and how we should strategically apply the knowledge that we have. Also, the importance of the social. Learning is such a deeply social affair. Even when we're working on our own, we are deeply influenced by the norms and cultural practices and social cues that we get from our environment. We are really oriented to learn from one another. Michael Tomasello said, we are the only species that tries to teach. We inform, and we learn from each other. Now, all of these are great insights, but you all work with 35, 40, 150 kids a day, maybe more. How do you actually turn these insights that come from basic science into a classroom reality? I'd argue that we actually need a different kind of research, one that happens a lot in my field of the learning sciences, where we turn the classroom into this place where we're really trying to develop the deep understanding of science. We call that design-based research. But what it does is says, like, this is a really different problem to think about how we build a learning trajectory, how we catalyze interest in the classroom, and take advantage of the social. This is a new problem, and we actually have to undertake that together. It's not something that research can answer alone in a laboratory. We actually have to study this in the wild, in the classroom. And that's something that I want to bring today as a starting point for us to think together about. One of my mentors from my graduate school is Sarah Michaels. And she was at Clark University, and she and her colleague, Kathy O'Connor, developed a set of resources that many of you probably know and use. But what I want to mention here is the origin story of this work. This work didn't start in a lab. It started in a classroom. It started with Kathy and Sarah going out and observing teachers who were masterful at orchestrating productive classroom talk. When I say productive classroom talk, they could get students talking for 30 minutes or more about academic content. And so Kathy and Sarah went out and they watched hundreds of episodes, and they tried to abstract this, and over many, many years, they developed what some of you probably know in mathematics as accountable talk, a set of talk moves and norms that can be used to support productive academic talk in mathematics. And more recently, they've developed talk moves in science. Some of you have probably seen from Turk the Talk Science Primer if you've been doing next generation science standards work. And I'm going to show you a video in a moment to get us thinking about what can we abstract from these kinds of classrooms. But I do want to say a little bit about, well, why talk in the beginning? Why are we going to focus? Because I'm going to have you focus on talk as a clue about active learning. So one is that talk is a really important piece of active learning because talk is a way that a teacher, you the teacher, get a sense of the variety of perspectives that students are bringing. We can only work with and transform students' ideas if we know what they are and if students engage in some elaborate talk. If we're just asking questions where we know the answer ahead of time and there's one-word answers, we don't know if kids can reason and really solve problems. A second is that students get an idea when hearing from each other about different perspectives on particular phenomena. And finally, and this is, I think, really important, when we talk about mathematics and science practices of argumentation, of modeling, of asking questions, talk is actually an integral part of that practice. It's not just a means to an end. It's part of what it means to become proficient in mathematics and science. So I'm going to set this up, but what we're going to do together is I'm going to actually pause my talk and give you a chance to talk at tables. I'm going to show about a 3-minute video. And this video comes from the Next Generation Science Exemplar Project. Some of you may have heard of this. And the video comes from an older source from Turk called the Inquiry Project, funded by the National Science Foundation. And as you watch this video, I want you to be thinking about what are some principles that we can derive from this particular video clip, whether they are directly inspired by it or by your reaction to it. It's okay if it's not actually in the video exactly, but try to key off of what's in this video. Notice what the students are doing, notice what the teacher is doing, and what is the nature of the task before them. This is, what you're going to see is a discussion that is right after a group of students have conducted an experiment where they're trying to explain what causes the amount of displacement of water when 3 different objects are dropped into a beaker. 2 of the objects are pretty heavy objects, and they're cubes, and then there's a larger, lighter weight plasticine object. And so you're hearing the kids talk about what happened and reasoning about that after that. So we will see if we can get this going. There are transcripts, too, of this on your table. So after I am done, you'll have a chance to actually use this to refer to in your discussions. All right. So your task is at your tables to talk about what principles of active learning, what is active learning? It would be part of a definition that is inspired by this video. And I'm going to give you about 5 minutes to talk at your tables, and then we'll come back and I'll facilitate a brief discussion to see if we can get some of those up here. And Marianne Baker from SRI, my colleague, if it reads to write some of these down on a slide so that you see them officially represented in a definition of active learning. So, is there a group that would like to offer a principle here? All right. Yes. Maybe I should get that microphone.
The teacher wasn't telling them what to think. They were creating their own thinking.
Kids are creating their own thinking. All right. Another principle. And so you want a new one, or is it something you want to add to that one?
Adding to that one.
Oh, great.
Okay, so the kids asked the questions to other classmates. So they were facilitating the discussion with each other.
And why is that a good example of active learning, you think?
So because then the teacher is the facilitator of that discussion, and I think they drive what they want to know.
New idea, or you want to add to it?
I'm adding to it. The kids were listening to each other, which instead of feeling that they had to listen to the teacher, they were listening to each other's ideas, and the teacher was asking them to respond to each other.
And what do you think the impact of having to listen to one another is on the learning in that classroom?
They thought through all the ideas that the other students had, the right ideas, and could construct the model within themselves of what they thought was right and what they thought was wrong.
So lots of different perspectives. All right.
Not just for active learning, but for just as how you run your classroom. The teacher obviously has made it to where it's a non-threatening environment, that if they say something that later turns out to be wrong, they're still not afraid to say it.
That's a great point. This is not the first conversation of this kind probably that's happened in this classroom, right? Yeah.
The other thing that we talked about is allowing students the time to reflect. And that's always hard as teachers. You know, we're thinking we have to get to the next thing, but we know ourselves we need time to reflect and think about our ideas before we talk about them further.
Great, so think time is part of this. I have time for 2 more, so these last 2.
We talked about how when the teacher instructed the students as they were talking, she was helping them to develop the language of argument that really allowed them to emphasize the limitations of one idea as opposed to having a single correct answer. And when you're talking about the limitations of an idea, then everybody's involved in constructing meaning instead of looking at a flaw and saying, oh, that was wrong, let's move on to, does somebody else have a different answer that might be more right? And so that was part of that safe learning environment you were talking about.
So it's not just, let me see if I have this right, it's not just that this argument is right or wrong, but actually they're learning about norms of argument and that, okay, great. Last time.
We discussed that when the students responded to each other, they responded with an expectation of support. So either through observation or data or inference or prior experience, they supported and justified their statement based on something.
Great. So students were expected to support, it's part of those norms, right, of being expected to support your argument with evidence. Thank you, Marianne. Will take me a minute to get back up. So just a few more ideas I want to put on the table, some exciting new directions in my field, inspired and conducted in exactly the way that Sarah Michaels and Kathy O'Connor have developed their work. One of them comes from my colleagues Vicki Hand at the University of Colorado Boulder and Beth Van Ness of the University of California Irvine. And what they've been doing is studying teachers who do an especially good job of promoting equitable participation in the classroom. And like Kathy O'Connor and Sarah Michaels, they've taken the approach of trying to abstract from teachers who do this really well some principles for that. And I wanted to name a couple of ideas that come out of their work. One is this idea of expanding smartness. One of the things they notice teachers doing is that they really name some of the skills and competencies of all students that are developing, maybe just as they're emerging, but really to help students gain confidence and to remap and move away from the deficit conceptions they may have internalized from teachers in the past or from students about their abilities. And the other thing too is, we talked about support in terms of argument. You notice that the teachers call on one another to support each other, and the teacher expects the students to support her in helping to lead the class. Notice that this teacher is down here in the corner, in the right-hand corner, while a student is showing how she's solving an algebra problem. That's the kind of position and where we are in space matters to really signal to the students that they're expected to help lead this effort. I've not said much about how is it that we actually catalyze and build off of student interest and make the learning about the role, connect to students' experience in their community. But my colleagues at CU Boulder and Northwestern University, in collaboration with teachers in Denver and Illinois, one of whom is right here, Michael Fumagalli, we're developing a series of project-based units together in science that attempt to do just that, really connect to students' everyday experiences. We're using an approach to developing units called, aligned to the next-gen science standards called storylines that are organized around student questions, but that also address key standards-based ideas. And they're anchored in what we're calling citizen engineering design challenges, where young people contribute solutions to community problems related to the content they're studying. In each of our units, there's a community partner that young people can connect to. And we've used student input as well to help us select these challenges, surveying students about potential driving questions for units to see what they might be interested in studying. And here you see students at the conclusion of one engineering design challenge planting a tree that's been provided by the Denver Parks and Recreation. The students choose what tree to plant. They're given a set of constraints that they had to work with in the unit and that they had to justify using what they'd learned about their schoolyard ecosystem. Other units we have organized in our evolution unit. Students make an infographic that will hang in their community health clinic about why antibiotic resistance is increasing. And in our genetics unit, There will be cafe scientific style democratic dialogues organized around the ethics of contemporary genetic engineering technologies like CRISPR. So we're doing that work as a way to connect more to interest. At a larger level, I wanted to call out the work of Nicole Pinkard and her colleagues in the audience in the Chicago City of Learning. As we think about more and more the way that learning is something that happens not just in school but everywhere, how do we help students and young people find their passion wherever that may be, and also to level up in that passion, get better at it over time? So she and her colleagues, Sybil Madison Boyd at DePaul, working with folks in a local writing project, have developed pathways that students can access online through something called the Chicago City of Learning. More than 100 organizations are part of the Chicago City of Learning and provide information about all the after-school and summer learning programs that are offered both by the school system and community organizations. And part of really building a more equitable system is to really create an expanded number of pathways that are both accessible and visible to young people, as they are on this website, for people to pursue STEM careers and interests related. So again, a few big ideas. These are your ideas. I want to start to really carry you forward in the day. Kids are constructing meaning. They create their own thinking here. It's non-threatening classroom space. Give students time to reflect. Students develop the language and norms of argument, and students support argument with evidence. And then to summarize some of the things that I've been saying today, it's really valuable to anchor learning in problems that are meaningful to young people and the phenomena that for them to explain. We have to connect our learning to student interests, experiences, and their experience of community. Make use of student questions to drive instruction forward. That is the heart of our storyline approach, is that our anticipated student questions are what move things forward. Support students in making sense of and building on others' ideas. Expand smartness. Ask students to assist teaching the class. And then we have to expand more broadly the number of accessible and visible pathways into STEM at the level of the community. So a few weeks ago, as Joe mentioned, the White House Office of Science and Technology issued a call to action to educators in K-12 and higher ed, professional development providers and nonprofit organizations, federal agencies and industry, and for all of us to participate in this effort to meet the goals of STEM for all through the use of active learning at all grade levels and in higher education. What I think we've talked about today briefly, the ideas we've generated together, as well as some that I've suggested and where research is headed that's exciting, all provide us with the elements of the vision, I think, that can guide us. But reaching every classroom demands that we all work together. Researchers and educators working together to devise and test strategies that can scale and be sustained across many classrooms. We have to treat this scaling and sustainability problem as a problem in its own right, one that requires us to confront directly the disparities in access to time and resources for teaching mathematics and science in ways that promote active learning. In our work in Denver, we're not just writing curriculum in this respect. We're working with leaders in Denver public schools in curriculum instruction, like Dawn Bauer, who's one of the awardees here in the room, to build the capacity at the level of the district for this kind of work. We need many more of the partnerships like ours in rural areas, suburban areas, and urban areas that blend the wisdom of practice with evidence from research. This is a big challenge, and I know that the people in the room are up to it. So thank you.